Hey guys, hope you are good. So today I'm gonna teach you relativistic relation between energy and momentum. And I guarantee you that once you understand this topic, you're not gonna forget it, at least till your exams. I'm also give you some tricks to remember the derivation and some must remember points in the derivation. So, relativistic relation between energy and momentum. So gentlemen, we already know that E equal to mc square, which we already derived in our last lecture, and m equal to m naught upon under root 1 minus v square upon c square. So putting this value in this equation, and we will get E equal to m naught c square upon under root 1 minus v square upon c square, and this is our equation number 1. So moving forward, we know that m naught is rest mass of the particle, and the momentum of the particle P equal to mv implies v equal to p upon m. Okay, now putting this value in equation number 1, so putting this value in equation 1, and we get, so we get E equal to m naught c square upon 1 minus p square upon c square. Okay, now moving forward, then E equal to m naught c square upon 1 minus p square upon m square c square. Now multiplying numerator and denominator by c square upon c square under root. Now we know that m c square whole square equal to m square c to the power 4, and using this we get E equal to m naught c square upon 1 minus p square c square upon mc square whole square. Okay, implies E equal to m naught c square upon 1 minus p square c square upon e square under root. Now squaring both sides, we get e square equal to m naught square c to the power 4 upon 1 minus p square c square upon e square. Now moving forward, so we will get e square equal to m naught square c to the power 4 upon e square minus p square c square upon e square. Okay, implies e square equal to m naught square c to the power 4 into e square upon e square minus p square c square. Now e square cancel out each other, and we will left with e square minus p square c square equal to m naught square c to the power 4, implies e square equal to m naught square c to the power 4 plus p square c square. So now finally equal to under root m naught square c to the power 4 plus p square c square. This is our final outcome. So this is the relation between total energy E and momentum P of the particles. Now let me give you a quick recap of the derivation. First of all, we already know that E equal to mc square and m equal to m naught upon under root 1 minus p square upon c square, and putting this value in this equation, we will get our first equation. And then we know that momentum equal to mv. Finding the value of v, which is equal to p upon m, and putting this value in equation number 1, we will get E equal to m naught c square upon under root 1 minus p square upon m square c square. Then multiply numerator and denominator with c square, and finding the relation and equation in terms of E square, and then squaring both sides, we will get finally this equation, and taking this into the right hand side, and we will get our final equation. Okay, now the additional point which will give you more marks in the exam is you have to write relativistic relation between kinetic energy and momentum. So we know that K equal to E minus m naught c square. Putting the value of E in this equation, m naught square c to the power 4 plus p square c square under root minus m naught c square. So this is one more relation. If you write this relation also in this equation, in this derivation, you will gonna definitely get more marks. So this is all about this topic, gentlemen. Hope you understand this concept. Please subscribe to my channel, like the video, and share among your friends. If you have any suggestion and want any separate topic to be discussed here, do comment below. In our next video, we will learn massless particle. Thank you.